Alright, so question 14, let z equals a plus ib, where a and b are real. If z over z minus I is real, show that z is imaginary or zero. Right, so first thing you want to do here is replace the z's with what is given, so it will become a plus ib over a plus. So in this case the brackets are not necessary, as you need them to put the i's together to form a complex number through factorization, which would be and now we have a complex number in the denominator, so we want to kind of rationalize it, as we never want a I in the denominator. So times it times the numerator as well, which will give us a times a is a to the power of 2. So for the denominator you don't have to worry about what this times, my bad, what this times this is, or this times this is, as there's a plus here and a minus here. There's kind of like a formula. They just need to times the kind of left hand side of the equation with the left hand side and the right one with the right hand side, so which would be this. So plus I times minus I is minus I to the power of 2 and b minus 1, b not minus 1 is that. Alright, now you just expand the numerator and the denominator, I guess, so you would get 2. So we all know that I to the power of 2 reverses the sign, the coefficient, so it becomes plus b, and the I also gets out as well. So let's just write that. So it becomes plus b times b, which is b plus b to the power of 2, and then b times minus b is b times minus 1 is just minus b. Then a to the power of 2, and then I to the power of 2 gets out and becomes a plus, so plus b minus 1 to the power of 2. Alright, now let's just get rid of the top bit to make some space. Alright, now we just want to make the numerator, the the numerator a complex number, so we put all the i's together and stuff. But first we need to get rid of, hold up, we need to get rid of minus abi and plus abi, so that's done. So now anything without the I comes together, so a to the power of 2 plus b to the power of 2 minus b, put these together. Then now the I, so plus a, I, then just write the denominator. Just make some more space. Alright, so here is, I guess, the tricky part. We don't have a complex number in the denominator, but we do in the numerator, as there is an imaginary here and a non-imaginary set of numbers here. So it is given that a and b are real, which means that we shouldn't have an imaginary number, so we have to get rid of the imaginary. So this part should equal to 0, which means that im, which is kind of like the right side of the complex number, which would have the I in it, of z over z minus 1, which is what we just expanded. So im, so the right side of this will just become a I over a to the power of 2 plus and whenever you're dealing with REs or IMs, you shouldn't put the I, so it's just the A by itself. And since it is saying that A and B are real, we have so AI should equal to 0. So you just left with Z equals A, not Z equals A plus IB, so make that equal to 0. And once we times all of this by 0, we will have A equal 0. So now we have the A. So let's see, 1 second, just make some more space. Alright, so now that we have the A, let's continue what we would have left. So C equals A plus IB would become IB by itself. And so I is an imaginary, which makes B a multiple of an imaginary. So and we've made im equal to 0, so that A and B are real. So yes, z over z minus I would be pure imaginary or 0. So we can kind of I guess write the conclusion like this. This pen is not working. So if that's what you need to write for the conclusion, and I guess the marker will get what you're saying. So if a equals to 0, then z must be either 0 or imaginary, as z equals a plus ib becomes z equals ib by itself. Alright, if you didn't get the video, just watch it again. If not, just write it down. I don't think you'll be in your test. And yeah, thank you for watching. I'll see you later.